Welcome back, everyone, for another deep dive. This time, we're going to be exploring the fascinating and sometimes mind-boggling world of quantum physics.
Yeah, it can get pretty weird.
It definitely can.
Yeah.
And we're diving into this topic with a Work Lizard post that summarizes a BBC documentary series called The Secrets of Quantum Physics.
Hosted by Jim Al-Khalili.
Exactly. Hosted by Jim Al-Khalili. And get ready, because we're about to enter a realm where things can be in multiple places at once.
It really does challenge how we normally think about reality.
It really does. So the first episode is titled Einstein's Nightmare.
Oh, that sounds intriguing already.
It does, doesn't it? And it takes us back to the early 1900s when scientists were trying to figure out something seemingly simple:
What's that?
how light bulbs work.
Huh. You would think that would be pretty straightforward.
Right. But this seemingly simple question ended up leading to the discovery of quantum mechanics.
And that's where things get really interesting.
Exactly. It completely changed our understanding of physics. Like, before quantum mechanics, we thought of electrons as tiny little balls orbiting the nucleus of an atom.
Right, like a miniature solar system.
Yeah. But quantum mechanics suggests that it's way more complicated than that.
It is. In quantum mechanics, an electron is more like a blurry cloud of possibilities. It can actually exist in multiple places at once.
Okay, wait, hold on. How can something be in multiple places at once? That doesn't make sense.
It's one of the most mind-boggling concepts in quantum mechanics. It's called superposition, and it means that we can't know for certain where an electron is until we measure it.
So you're saying it's the act of measurement that forces it to choose a specific position.
Exactly. Before we measure it, it exists in this weird state of being in all possible places at the same time, and that's one of the things that really bothered Einstein.
Oh yeah, Einstein. He was not a fan of this whole chance element in quantum mechanics.
Not at all. He famously said, "God does not play dice with the universe." He really believed that there had to be some kind of underlying order to the universe.
Some hidden variables that would eliminate the need for chance and randomness.
But quantum mechanics just didn't fit with that worldview, did it?
Not really. And that's where the conflict between quantum mechanics and Einstein's own theory of relativity comes in.
Because one of the implications of quantum mechanics is this idea of entanglement, right? Where two particles can become linked and their fates are intertwined no matter how far apart they are.
It's one of the strangest phenomena in physics, and it seemed to completely contradict Einstein's theory that nothing could travel faster than light.
So did anyone try to, settle this debate between Einstein and quantum mechanics? I mean, he had some pretty strong doubts about it.
Well, in the 1960s, a physicist named John Bell came up with a really clever experiment to test these ideas.
And I read that the documentary actually recreates this experiment, like a modern-day version of it.
They do, and it raises a really profound question. Does reality exist independently of us?
Mm-hmm.
Or do we somehow play a role in creating it through observation? Whoa, that's deep. I may have to think about that one for a while.
It's a mind bender for sure, and it's a question that physicists are still grappling with today.
I bet. So, where do we go from here? What else does this documentary explore?
Well, in the next episode, things get even more interesting because we start to see how quantum physics might actually hold the key to understanding life itself.
Wait, hold on. We're going from subatomic particles to living creatures. How does that even work?
Get ready, because things are about to get even weirder.
Okay, you've definitely got my attention now. I'm ready to dive into episode 2. So episode 2, Let There Be Life.
Mm-hmm.
I gotta say, I'm really intrigued to see where this goes. Quantum mechanics and biology. That's an interesting combination.
It is, and it really challenges us to think about these concepts in a whole new way.
Yeah, so far we've been talking about all this mind-bending stuff about the subatomic world, and now we're going to see how it might connect to living things.
Exactly. And they start with a creature that you might not expect, the robin.
A robin. Wait, what do robins have to do with quantum mechanics?
Well, scientists believe that these little birds might be using one of the weirdest phenomena in quantum mechanics to navigate quantum entanglement.
Hold on, you're telling me that the robins I see in my backyard might be harnessing quantum entanglement? I'm not sure I'm following.
It is pretty mind-blowing. Remember entanglement. It's when two particles become linked and their fates are intertwined no matter how far apart they are.
Yeah, like they're communicating instantly.
Right. Spooky action at a distance, as Einstein called it. So scientists think that robins might have a special protein in their eyes that's sensitive to the Earth's magnetic field, and this sensitivity could involve entangled electrons within that protein.
Okay, but I'm still not sure I see the connection. How does that help them navigate?
Well, by sensing these subtle variations in the magnetic field, the robins can create a sort of internal compass. It's like they have a built-in GPS system that helps them migrate across vast distances.
Wow, so these tiny birds might be using quantum entanglement to travel thousands of miles. That's incredible. And are robins the only ones using quantum mechanics? What about, like, us? Could we be using it too? I
Yeah.
read something about our sense of smell being connected to quantum principles.
You're right, it's not just robins. There's growing evidence that even our sense of smell might be based on quantum mechanics.
Really? I always thought smell was just about the shape of molecules fitting into receptors in our nose.
That's the traditional explanation, but it might not be the whole story. The quantum theory of smell proposes that our noses aren't just detecting the shape of scent molecules, but also their vibrations.
Vibrations, what do you mean?
So everything in the universe vibrates at a certain frequency, and these vibrations are quantized, meaning they exist at specific energy levels.
Ooh, okay.
And the idea is that our olfactory receptors might be sensitive to these subtle quantum vibrations in the molecules.
So our noses are like tiny quantum sensors. That's wild. But is there actually any evidence to support that idea?
It's still a fairly new area of research, but there have been some intriguing studies that suggest it's a real possibility.
That would definitely change our understanding of how our senses work. It's amazing to think that quantum mechanics could be happening right under our noses, literally. So what else? Are there any other examples of quantum mechanics in biology?
Oh yeah, there are a lot more. The documentary also dives into how plants use quantum mechanics during photosynthesis.
Photosynthesis, really? I thought that was just basic biology.
It is, but the way plants capture and transfer energy from sunlight is incredibly efficient, and scientists think that quantum mechanics might be the key.
Okay, I'm listening. How does that work?
Well, it all comes down to the uncertainty principle, which we talked about earlier.
Right, the one that says you can't know both the position and momentum of a particle with perfect accuracy.
Exactly. And what scientists have discovered is that during photosynthesis, the energy from sunlight doesn't just follow a single predictable path. Instead, it takes multiple paths simultaneously.
Multiple paths at the same time.
Yep. It's like the energy is exploring all possible routes to find the most efficient way to reach the reaction center where it can be used to create glucose.
Huh, that's pretty efficient. And it's all thanks to the uncertainty principle.
Exactly. By taking advantage of the uncertainty principle, the energy can avoid obstacles and find the quickest path, which makes photosynthesis incredibly efficient.
Wow, so quantum mechanics is helping plants make food. That's amazing. And the documentary doesn't stop there, does it? It also talks about quantum tunneling and evolution, right?
Yeah, that's one of the most mind-boggling possibilities raised in the episode.
Okay, first of all, what is quantum tunneling?
Imagine a particle passing through a solid wall that it shouldn't be able to penetrate. It sounds impossible, but that's quantum tunneling.
Whoa, that's crazy. How is that even possible?
In the quantum world, a particle's position isn't precisely defined. It's more like a wave of probability, meaning there's a small chance it can be found on the other side of a barrier, even if it doesn't have enough energy to get over it.
So it's like it's teleporting.
Kind of. And the crazy thing is, some scientists believe that quantum tunneling might actually play a role in mutations, the changes in DNA that drive evolution.
Wait, so you're saying that quantum mechanics could be influencing evolution. How does that work?
Well, imagine a proton, which is a positively charged particle in the nucleus of an atom, suddenly tunneling to a different location within a DNA molecule. This could potentially alter the genetic code and lead to a mutation.
Whoa, that's a pretty big deal. So instead of a chemical reaction causing the mutation, it's this weird quantum event.
Exactly. It's definitely a controversial theory, but if it's true, it could revolutionize our understanding of how new traits emerge and how species evolve.
Mind blown. So we've got robins navigating with quantum entanglement, our noses possibly detecting quantum vibrations, plants harnessing the uncertainty principle, and now even evolution potentially being influenced by quantum tunneling. It's like quantum mechanics is everywhere.
It really does make you wonder about the true nature of reality, doesn't it?
It does. And it brings us back to that question from the first episode. Do we create reality through observation? If quantum mechanics is so deeply embedded in biology, does that mean that our consciousness, our very act of observing the world, might be influencing the reality around us?
That's a profound question, and honestly, I don't know if we have the answer yet, but it's definitely something worth pondering.
It is. This is also fascinating, but I have to admit it's Also a lot to take in.
Yeah, it's a lot to process, but that's what makes quantum mechanics so intriguing. It challenges us to think beyond our everyday experiences and to explore the mysteries of the universe.
So we've covered a lot of ground here, from robins using quantum entanglement to navigate to plants harnessing the uncertainty principle during
Yeah.
photosynthesis. It seems like quantum mechanics is woven into the very fabric of life.
Yeah, it's pretty amazing, and it makes you wonder just how deep this connection goes.
It really does. And it keeps bringing me back to that question from the first episode,
Yeah.
the one about whether we play a role in shaping reality through observation.
Right. Does reality exist independently of us, or do we somehow influence it by observing it?
Exactly. And with all these examples of quantum phenomena happening in living organisms, it makes you think, maybe our consciousness, our very act of observing the world, could be having an impact on the reality around us.
It's a pretty mind-blowing concept, and it's one that's been debated for a long time. But quantum mechanics definitely adds a whole new layer to the discussion.
I agree. I mean, if quantum mechanics is so deeply intertwined with biology, could our thoughts and observations actually be influencing the behavior of those quantum particles?
Some physicists believe so. There's a school of thought that suggests consciousness might be a fundamental aspect of reality, just like matter and energy.
So we might not just be passive observers of the universe, but active participants in creating it.
That's the idea. And while it's still a relatively new and somewhat controversial idea, it's definitely gaining traction in some circles.
It's certainly a radical shift in perspective, but it's also really empowering. If our consciousness does play a role in shaping reality, then maybe we have more power to influence our lives and the world than we realize.
It's a fascinating thought, and it opens up all sorts of possibilities. But I think it's important to remember that we're still in the early stages of understanding quantum mechanics and its implications.
Right, there's still so much we don't know.
Yeah.
So where do we go from here? What are the next steps in exploring these ideas?
Well, I think the most important thing is to keep an open mind and to keep asking questions. The more we learn about quantum mechanics, the more we realize how much we still don't know.
And who knows what incredible discoveries are waiting for us down the road.
Exactly. It's a journey of exploration, and it's one that we're all part of.
I couldn't agree more. This deep dive has definitely been a wild ride.
Yeah, it has. And it's left me feeling both humbled and inspired.
Me too.
Mm.
It's amazing to think that we're just scratching the surface of understanding the universe and our place in it.
It really is. And it makes you appreciate the mystery and wonder that's still out there.
Well, it's time for us to wrap up this deep dive into the world of quantum physics. But I have a feeling these ideas are going to stay with us for a long time.
I think you're right. Quantum mechanics challenges us to rethink everything we thought we knew about the universe.
And it's been a privilege to explore these mind-boggling concepts with you. Thanks for joining me on this journey.
The pleasure was all mine.
And to all our amazing listeners out there, thank you for tuning in and for joining us on this exploration of the quantum realm. We hope you've enjoyed the ride.
And remember, keep exploring, keep questioning, and keep your minds open to the infinite possibilities of the universe.
That's a great way to end it. Until next time, folks.